J. L. Zhao and Y. A. Sun 2001 doing a research where they aware the presence of Levy flight behavior in the model is due to the existence of singularities in the energy increment function psi. As a result of the Levy flights, the diffusion of the comet motion in the energy space is enhanced. This model is extended to a more general dynamical system where the variance of the probability distribution increase with time according to some power laws with some arbitrary powers. Researcher E. Harnett 2012 indicate that second-order diffusion reaction models are not well suited to simulate the spatial spread of biological species that follow a Levy random walk, as they are inclined to underestimate the speed at which these species propagate. D. Raibel and S. Mohanty 2009 found the model using Levy flight predicted that bioturbulation depends on the organism density with the approximate square root dependence on biomass over a wide range of density. A research regarding quantum manifestation of Levy type flights in a chaotic system by A. Iomin and G. M. Jeskalowski 2012 discussed about the semi-classical dynamic of quantum wave packets spreading for a kicked rotor. Quantum flights are established for a specific magic value of a chaos control parameter when the classical sickness of trajectories is most effective. By dividing of a survival probability and distribution of the acceleration, the presence of quantum Levy flight is identified. A. Grinesco and A. B. Chekchin and N. F. Shaulga 2004 do a research on anomalous diffusion and Levy flight in channeling. They found that existence of such regularity possibility of the short-term trapping of particles in the regime of plane channeling with subsequent escape from this regime. C. Howdre and 2012 do a research on small-time expansion of the distribution densities and option prices of stochastic volatility models with Levy jumps. Resulting gain from their research show that the approach allows for a unified treatment of general payoff function of the form phi x Lx is greater than equal to z for smooth function phi and z is greater than 0. As a consequence of tail expansion, 10 the polynomial expansion in T of the transition densities Ft are almost obtained under mild condition. H. Takanashi et al. 2002 does an experiment regarding generalized entropy approach to stable Levy distribution with financial application. The theoretical analysis and comparison with measured values indicate the usefulness and fitness of the present theory for investigation of the Levy distribution, fluctuation-driven directed transport in presence of Levy flights has been identified by D. Del Castello, Nigret and et al. 2008. Even in the absence of an external titling force or a bias in the noise, the Levy flights drive the system out of the thermodynamic equilibrium and generate an uphill current. Now the highlights on Levy flight. From the review, researchers found that Levy flight technique is a universal technique. Use and effectiveness of the Levy flight attracts many researchers. This can be seen from the emerging innovation of the Levy flight technique. At present time, Levy flight technique has been enhanced to two different studies by researchers. The ongoing studies on Levy flight produces new enhances techniques such as truncated Levy flight, gradually truncated Levy flight, arbitrary truncated Levy flight, smoothly truncated Levy flight, fractional Levy flight, annealed exponential Levy flight, and Levy flight as shown in figure below. Truncated Levy flight is a process to show a slow convergence to a Gaussian. It was introduced by Magenta and Stanley and has been used in ecophysics. In turbulence and in plasma physics, the truncated Levy flight is a Markovian jump process with jumps showing the length of power law behavior up to some large scale. At larger scale, the power law behavior crosses over to a faster decay so that the second moment of the jump length is truncated Levy flight is an attempt to overturn such drawback. The standard Levy distribution is thus abruptly cut to zero at a cutoff point. The truncated Levy flight is not stable though but has finite to sharp truncation. The characteristics function of a truncated Levy flight is no longer infinitely visible as well. However, it is still possible to define a truncated Levy flight with a smooth cutoff yields of infinitely divisible characteristics function. In a smoothly truncated Levy flight, the cutoff is done by asymptotic approximation of a stable distribution valid for a large value. Yet the STLA breaks smoothly truncated Levy flight, the cutoff is done by asymptotic approximation of a stable distribution valid for large values. The STLA breaks down in the presence of positive feedbacks. The cutoff can still be alternatively combined with the statistical distribution factor to generate a gradual truncated Levy flight. Nevertheless, this procedure also brings fatter tails. The gradual truncated Levy flight GTLF itself will break down if the positive feedbacks are strong enough. This apparently happens because the truncated function decreases exponentially. As exponentially damped Levy flight is a distribution that might be assumed to deviate from the Levy in both a smooth and gradual fashion in the presence of positive feedback that may increase. So in conclusion, enhanced and until the now, there are various branches of Levy flight techniques that have been applied such as truncated Levy flight, gradually truncated Levy flight and smoothly truncated Levy flight. And their application is shown below.